So good evening, everyone. So and happy new month. Happy new month. So today we'll be starting from where we left at last week, which is still our continuation of network security. I think this is the longest part of the all modules, the security, the network security. We've been doing it for like more than a week now. We should be able to finish it today, by God's grace. So this is where we stopped at last week. So segmentation for embedded systems and IoT, right? So let's start from the definition of embedded system, basically. So embedded system is a programmable hardware component with a minimal operating system and software. That's the definition for embedded system, right? And most of them are designed to perform a dedicated function or functions. And most of all these embedded systems, right? They don't, when they are building it, they don't put security into consideration while building the, embedded system. So most of all these embedded systems, they are difficult to add patch to. They are firmware. Most of them, you cannot update them. Most of these embedded system and IoTs, you can't, it is difficult. It's either difficult to, add updates to their firmware, or there is no even way at all to add updates to their software or firmware. So most of the time, if there is any vulnerability in this embedded system or IoTs, there is no way they can actually resolve the issue because the patch or the update cannot be sent to all the software. So basically, we actually get what I'm trying to say when we started. Just want to give you the intro towards embedded system and IoT. So, and we understand the concept of segmentation, right? We've talked about segmentation like many times. It's just a way of trying to isolate some, group of devices or group of departments from communicating to another devices, right? So like creating a separate LAN for some group of devices so that they can operate on their own at that space without actually affecting other devices at every other space or department. So an embedded system is a computer implemented as part of a larger system, right? They just integrate it to the system. They are not the core part of the system, right? So they are just basically integrated into the system. The embedded system is typically designed around a limited set of specific functions in relation to the larger product of which is a component. So examples of embedded system include network attached printers. They are not a core part of the network. They basically attach them, they integrate them to the main, network or to the mainland. So we have smart TVs. Smart TVs is not necessarily part of what it is organization assets, but it doesn't really perform the operation that, it's just integrated to perform some specific function, but not the core function of that organization. So HVAC, like heating, ventilation, air conditioning controls, smart appliances like our smart refrigerator, our smart wristwatch. You have some staffs or employees that will come into the organization wearing those IoTs, those smart wristwatch to the organization, and eventually they will connect all those smart watches or all those smart cameras to the organization network. So bringing all of those to the organization adds, it actually increased the attack surface or attack vector of the organization, because most of all these embedded systems or smart wristwatch don't have a firmware that you can add an update to if anything goes wrong. So basically, they are easily hackable, right? So bringing it to the organization network will cause problem to the secure organization. So the Internet of Things. So let's talk about the Internet of Things, right? The Internet of Things is the collection of devices that can communicate over the network with one another or with a control console to affect and monitor the real world. So anything, it may be animate things, inanimate things, added to your network. It can be your computer, it can be anything, right, that can be added to the internet or to the network. These are called IoTs, Internet of Things. So IoT device might be labeled as smart devices or smart home equipment. And most of all these IoTs, they are embedded into the system too. So many of the ideas of industrial environmental control found in office building are finding their way into more consumer available solutions for small offices or personal homes. So embedded systems and network-enabled devices like IoTs that communicate with internet are considered IoT devices and need special attention to ensure that communication is not used in a malicious manner. Like I said, most of these embedded system or IoTs, right, they will add more attack surface to the organization network because they are vulnerable to some types of attacks that cannot be resolved. So you bringing all these IoTs and embedded systems to the network will cause problem to a secure network. So since many of these devices have multiple access routes, such as Ethernet, most of them you can use wire to connect to your network. Some of them are wireless, some of them uses Bluetooth, etc. Special care should be taken to isolate them from other devices on the network. Like I said, most of them are not secured, right? So you have to kind of like create a separate environment for all of these embedded systems or IoTs so that eventually, or if they were able to actually hack these IoTs or embedded system, it will be on that segmented network, right? So that even if they are going to hack all these IoTs or embedded system, it will not affect the main network. So that's where segmenting the embedded and IoT system comes into the picture, right? So the characteristics that make embedded system operate efficiently are also a security risk, right? Like I said, embedded systems are often used to control something physical, such as valve for water, right? There are some like a group, if you have a group of IoTs, right? Or if you've seen IoTs, there used to be one, management console whereby you can go to, like smart wristwatch has some of your health, I think yes, like your heartbeat, the how many minutes you used to work, all of those things. So they have your health information. So you will just take your phone and you just log into the management console and we see all of those information inside that management console. Maybe you can authenticate through the mobile application or through internet or anything, right? So these devices have a limited instruction set and are often hard-coded or permanently written to a memory chip. These devices have a limited instruction set and are also okay. For ease of operating the mechanical parts, the embedded system is often connected to a corporate network, since and may operate using the TCP/IP protocol. Yes, the same protocol that runs all over the internet. You know, we talked about TCP/IP protocol, right? What's the full meaning? It's not transfer. It's not transfer. What is it called? It's transmission control protocol. And the IP part is what? Internet protocol. And like we know, they use them for the internet. So therefore, it is feasible for anyone, anywhere on the internet to control the opening and closing of a valve when the network are fully connected. We actually hear some news that some hacker hacked maybe one nation and they release all their water. You know, they open the water pump or the valve. So it is possible because all of these, you know, water valve, the heating, the ventilation, everything, like we said, they have a management console, right? Where all of these things are controlled, right? So if they hack into such organization, they will just go to the management console and do basically anything with the embedded system or IoTs. So that's why most of the organization will be actually segment a network or isolate some network parts to these IoTs or embedded systems so that even if they are hacked, it will not affect the main network because they are easily hackable, like I said, because their firmware cannot be updated. Most of them, they cannot update their firmware. So the other side of the embedded system, which also applies to IoT devices, is the general lack of system updates, like I said. When a new vulnerability is found, in the case of most embedded systems with the programming directly on the chips, physical replacement of the chip will be required to patch the vulnerability. Imagine that you have a wristwatch or a smart wristwatch, and you know the vendor discovered that they've been able to actually hack into their program or software, and they can basically steal people's information through that IoT. And now that vendor is coming out to tell all of us that for you to be able to patch or add in that wristwatch, you have to buy one hardware somewhere. It doesn't make sense. So assuming that an organization have like thousands of that IoT, so that means they have to buy the hard chip to actually to patch the vulnerabilities instead of them to actually send out software like Microsoft do or like every other vendors do. But they are coming out to tell you that you have to go and buy one chip to update the wristwatch. It doesn't make sense, right? So that makes most of the embedded system or IoT vulnerable to the network. So for many systems, it may be cost effective to have someone visit each one to replace a chip or manually connect the chip to reprogram it. And any of those is actually hard to do. So we buy all these internet connected things because of the convenience. Cameras, light bulbs, speakers, refrigerators, they all bring convenience to our lives, but they also introduce risk. There are some refrigerator that will tell you that okay, you don't have this kind of grocery again in your freezer, that you have to buy it. You want to do it, but it's a vulnerability to your home and the organization as well, because there is no interface where you can update such refrigerator. Not all of them, but at least 95% of IoTs, they are not, they cannot add patch to them or updates to them. Like all these Tuesdays, Microsoft updates and co. The vendors, they don't have the capability to do it. So it makes it vulnerable to the organization. So the organization has decided that, okay, fine, if all these IoTs or embedded systems are going to cost us, a lot of risk, so let's create one segment, or let's isolate all the IoTs we have in our organization to this particular network. Let's separate it from our main network, and let's create another network for all the IoTs. So that if they are able to hack into the IoTs, it will not affect our main, network. So the figure below depicts one example of segmenting IoT devices from other network infrastructure. You can see this is their core network, right? And they have, okay, this is the firewall, right? And this is the router, right? And this is connected to the internet. Basically, this is the gateway, right? And this gateway is connected to the internet, right? So now this is their IoTs, like their camera, their smart bulb, their smart camera, their smart lock, their game, the IoTs. So they created another segment, another network. They isolate it from the main network. So if they are able to even hack into this, it will not affect this. It's like creating another separate department entirely. Okay.
What do you think are able to hack to this point instead of these points? Because what we have here and here, they are practically the same device or system that we have at this juncture. So what I'm saying is, what if they hack the entire? Is it not possible to hack the entire?
Yeah, it is possible.
Before the segment.
So it is possible. Like I said, they can hack into the network, right? But don't forget, like we said, there is no 100% security. But you put some, procedure, some protocol, some mechanism in place so that even if they are able to even hack into your organization, it will take time, right? So assuming they have a secured network and they are introducing something that is not secure to the network, that means it will cause all the whole network to be unsecure. But what they are doing here is that they are separating this device, right, that can cause problem to the main device from the main network. They can hack this device, but it will take time. But they can easily hack these IoTs.
Okay. What is contextually? What is saying is, if at all they are able to add any of these IoT devices, we want to do it to such a way that they don't have access to the main network.
So let's move to microsegmentation.
Since those IoT devices are naturally vulnerable.
So the two sets of current adversaries are polymorphic. When we say something is polymorphic, that means they have different size and different types. So in nature, and allow threats to bypass static security controls. So modern cyber attacks take advantage of traditional security models, so move easily between systems within a data center. So microsegmentation aids in protecting against these threats. A fundamental design requirement of microsegmentation is to understand the protection requirement for traffic within a data center, traffic to and from the internet, traffic flow. Basically, this microsegmentation is like dividing your department into sub-departments. They might possibly be on the same local area network, but they cannot actually interact with one another. So they have security implemented or integrated into each sub-department. So let's just move on. So if when organizations avoid infrastructure-centric design paradigms, they are likely to become more efficient at service delivery in the data center, become apt at detecting and preventing advanced persistent threats. So some key points about microsegmentation. So the first one is that microsegmentation allows for extremely granular restriction within the IT environment to the point where rules can be applied to individual machines and or users, and these rules can be as detailed and complex as desired. For instance, it can limit which IP address that communicates with a given machine, at which time of the day, with which credentials, and which services those connections can use. Right? So you segmenting your network, make it flexible for you to actually interact with a group of devices in that isolated area. So in those area, you can actually configure the rules to all those sets of devices that, okay, I allow this IP address, I deny this IP address, or these users are permitted and these users are restricted within that space, within that segmented area. So microsegmentation uses logical rules, not physical rules. Microsegmentation uses logical rules, not physical rules, because you have to configure it. It's not like administrative rules, whereby we have some kind of like, your boss telling you that, okay, when you come at 9 o'clock, this is what you will do. When you are leaving, this is what you will do. But this is, logical. You have to configure. You have to. It can be access control list. Example is access control list. So ACL. So it's part of logical, rules. Yes. So you have to tell the computer what to do. Right? So example can be the implicit rules that we configure in our firewall or the explicit rules. And does not require additional hardware or manual interaction with the device, because you just go to the, to the management console and you just, configure everything you want to do. It's like you having a firewall or a switch or a router, and you are trying to, interact with that router. You have to tell the router some things to do and some things not to do. By actually setting some rules, using maybe IP address or MAC address or anything, to actually tell the router or the switch what to do. So those are logical control. Okay.
I want to ask, IoTs, they have
yes, most of them have IP addresses.
like
yes.
Those smart refrigerators.
Yes, yes, yeah. Yeah. So yes, yeah, most of them have, yeah. And most doesn't. So microsegmentation is the ultimate end state of the defense in-depth philosophy. No single point of access within the IT environment can lead to a broader compromise. At least we all, by now, we should understand the meaning of defense in-depth. Don't tell me. Yeah, that's it. Also, microsegmentation is crucial in shared environments, such as a cloud, where more than one customer's data and functionality might reside on the same devices, and where third-party personnel, like admin, might have physical access to the device. Microsegmentation allows the organization to limit which business functions or units or offices or departments can communicate with others, to enforce the concept of least privilege. We understand the least privilege. What do you understand by this? Yeah. So also in modern environments, segmentation is available because of virtualization and software-defined network, SDN technologies. I don't want to go deep into that. I think even in your home, microsegmentation can be used to separate computer from smart TVs, air conditioning, and smart appliances, which can be connected and have vulnerabilities. So it's still the same thing we've been talking, like you trying to actually separate some set of devices from other set of devices. It's like trying to separate departments. Like you have IT department, you have admin department, you have sales department, like that. It's just like that. Everything that is going on in IT department cannot affect, sales department. It's just the same, logical thing. So VLAN. Have you done VLAN? Okay, we've not. In our network class. In our network class, but I've not gone into it. So basically, VLAN is virtual local area network. And this VLAN basically makes life, easier for admin and, ISPs, because it's like you trying to, we have ports in our switches, right? It's like creating another port inside one port, or in virtual sense. We are not seeing it physical, but it's being created inside. It's like having multiple ports inside one port. You can see all these red stuff, right? Assuming this is one VLAN, right? Inside this red, you can have up to like an additional 1,000 plus VLAN again. And supposedly it should be like one VLAN, two VLAN, three VLAN, four VLAN, like that. So assuming this is 8 ports. So basically the max VLAN that normally logically we should have should be 8 VLANs, right? But now we can have up to 8,000 VLANs. So, but I don't want to actually go to, because there's some concept to it. So basically you will take your switch, right? This VLAN cannot work without router, but it will be configured in your switch. It will not. That's it. It will not. So basically, they all have, it's like still talking about all the segments, say isolated area, right? So they have their own separate collision and broadcast domain. But it is virtual. It's not like physical. It is configured inside original VLAN. It's like duplicate of one VLAN. So, okay, like I was saying, so you will take your switch and you will configure the VLAN, right? So you can configure the VLAN using IP address or MAC address of that device. Then you configure the VLAN like switch port VLAN. Then you play the VLAN, maybe VLAN 10 or VLAN 1 or VLAN 2. You will name it, right? VLAN 10, right? Then we give that VLAN an IP address. So to have its own space, its own, collision and broadcast domain entirely. So VLAN allow network admin to use switches to create software-based LAN segments, which can segregate or consolidate traffic across multiple switch ports. Devices that share a VLAN communicate through switches as if they were on the same layer 2 network. We know that switch operates at the second layer, right? Using MAC address. So figure 4.19 shows different VLANs. We have red, green, and blue, right? All these are VLANs. Connecting separate sets of ports together while sharing the same network segment consisting of the 2 switches and their connection. Since VLANs act as discrete network, communication between VLANs must be enabled. So after configuring the VLAN in your switch, so you will go to your router to enable it. Then you will call out the name of that VLAN again, VLAN maybe 10 that you configured in your switch. You call it back your router, maybe VLAN 10. Then you will enable it using an IP address again. So VLAN must be enabled. Broadcast traffic is limited to the VLAN, reducing congestion and reducing the effectiveness of some attacks. Administration of the environment is simplified as the VLAN can be reconfigured when individuals change their physical location or need access to different services. VLANs can be configured based on switch ports. Like I said, you can use port number to configure VLAN. You can use IP subnets to configure VLAN. You can use MAC address, and basically you can use protocol to configure VLAN. VLANs do not guarantee a network security. If you have a VLAN, doesn't mean that you cannot hack you. They will hack you with your VLAN. So the type of attack used in VLAN is called VLAN hopping. That's the attack that is attached to the VLAN hopping. The VLAN technology is only one tool that can improve the overall security of the network environment. It can only improve it. It cannot prevent the attack from occurring or from happening. So another common use of VLANs in a corporate network is to separate the data center from all other network traffic. This makes it easier to keep the server-to-server traffic contained to the data center network while allowing certain traffic from workstations or the web to access the servers. As briefly discussed earlier, VLANs can also be used to segment network. We can use VLAN as well to segment network because they will be in their own separate area too, having their own broadcast domain and their own position. So they have their own segmented area as well. So earlier, I think one of those modules, we've talked about network access control, right? So like I said, this system uses VLANs to control whether devices connect to the corporate network or to a guest network. Even though a wireless access controller may attach to a single port on a physical network switch, the VLAN associated with the device connection on the wireless access controller determines the VLAN that the device operates on and to which network it is allowed to connect. Finally, in large corporate networks, VLANs can be used to limit the amount of broadcast traffic within a network. This is most common in networks of more than 1,000 devices and may be separated by department, location, or building on any other criteria as needed. You can use port number or you can use MAC address. So the most important thing to remember is that while VLANs are logically separated, like you said, they are not physical, they are logical, right? They may be allowed to access other VLANs. You can use VLAN, like assuming in one port, you have 10 VLANs. In port 10, you can go to port 11 and use port 10, VLANs in port 10 to access VLAN in port 11. So they can actually, interconnect with each other. So they can also be configured to deny access to other VLANs. You can configure one VLAN to stop people from connecting to another VLAN. So we have VPN. We have virtual private network, VPN. So our most belief is that, whenever we are using VPN, it is safe and nobody is going to hack us using VPN. But that's not the case. With the VPN, you can still be hacked. So a virtual private network is not necessarily an encrypted tunnel. It's simply a point-to-point connection between two hosts that allows them to communicate. So secure communication can, of course, be provided by the VPN, but only if the security protocols have been selected and correctly configured to provide a trusted path over an untrusted network. So while configuring or trying to, implement the VPN, you have to consider the protocols that you are selecting to use. We are using unsecure protocol, right, to connect to the VPN. That means the tunnel will be unsecure as well. So you can't use HTTP to connect over VPN. HTTP protocol is not secure. We all know that it's not secure. But you are browsing using HTTP. What do you expect? You have VPN, fine, you have VPN. But you are browsing over unsecure internet or network using HTTP. So that means you can be hacked because you are now in one zone that is not safe. Even though you have VPN on your network, it's not firewall, right? It's just VPN to connect to remote areas, right? But you are browsing over unsecure network, so you can be hacked. So remote users employ VPNs to access their organization network, and depending on the VPN's implementation, they may have most of the same resources available to them as if they are physically at the office, right? So most of the people working from home, right, they use VPN to connect to the on-prem, infrastructure of the organization. They cannot do that, right, except using VPN, because it will make them have access to everything in that organization as if they are basically in that organization, right? But they are far away from that organization. So VPN, we make it easier for them to actually work from home, using the organization infrastructure from home. VPNs, okay, as an alternative to expensive dedicated point-to-point connections, organizations use gateway-to-gateway VPNs to securely transmit information over the internet between sites or even with a business partner. That's everything you need to know on VPN, because that's where they stopped. So far, the chapter, covered computer networking and securing the network, right? So like we said, that a network is simply two or more computers linked together to share data, information, or resources, right? That's the definition of network. So there are many types of networks, like we mentioned, such as LAN, local area network. We have WAN, we have WLAN, and we have VPN. Some of the devices found on the network include hubs, switches, routers, firewalls, servers, endpoints, like your computer, your smartphone, your tablets. Other network terms include ports, protocol, Ethernet, Wi-Fi, IP address, and MAC address. We basically talked about all of these things. So we also talked about OSI and TCP/IP, right? So we also talk about attacks on networks such as denial of service and DDoS. I hope you can still remember. Sorry. Yes, that's DDoS. So these are the types of attacks that you can find on the network. Denial of service attack, DDoS, fragment, oversized packets, or buffering overflow. We have spoofing and man-in-the-middle attacks. I explained all of these attacks, right? We also discussed ports and protocols that connect network and network services, from physical ports like LAN ports that connect the wires to logical ports, e.g. So what port is port 80? HTTP. What about 43? HTTPS, yeah. And which one is insecure? Which one is secure? Okay. Okay. You don't need to, you are going to the question side of it. So some possible threats to network were examined also, including, okay, we've talked about. So this chapter discussed on-prem data center and their requirements. So we talked about, you can still remember, on-prem data center, like the one you have on site in your organization, those are called on-prem. And you can have power, heating, ventilation, and air conditioning, fire suppression, redundancy, and memorandum of understanding, all of those under on-prem network. Then we actually discussed about the cloud, the type of cloud, like software as a service, infrastructure as a service, platform as a service. We talked all about that. We talked about public, private, and community, and hybrid, so models of the cloud. Then we mentioned the terminology for network design, which includes network segmentation, such as microsegmentation that we just finished, demilitarized zones, DMZs, VLAN, and VPN. Also, we also talked about defense in-depth, zero trust, and network access control, or NAC. So coming up, we have some exercise to do, like we normally do. So people at home, we answer their own, and people on prem. And people on prem. So you cloud, you will answer your own, and people on prem too, we answer their own. You can go on from there. Hold on. Let me see. I think we have two charts. Okay. So the first question: what is a common network device used to connect networks? First one, we have server, we have endpoint, we have router, and we have switch. So you have 1 minute. So people at home, you guys have 1 minute as well. Fastest finger. We have router, we have router, we have 2 routers, 3 routers. Why are we picking out? Sir, what's the answer? Server. Bro, what's the answer? Router. Okay, let's see. Someone pick D and someone pick C. So what's D? D is switch. Someone picked switch, and someone picked router. We have 2 C's and we have 1 D. So since we have more router than switches, so let's pick router first and let's check the answer. Or maybe I should ask the reason behind your answers. So why did you choose server? You just feel like server is the answer. What's it?
It is more of a network so,
I said network device. Server to is network device.
Yes, it's a network device. What the server does is to connect network.
Okay. Okay. Or to save.
Yes, to save or make available for other devices.
Okay. That's
why.
That's good. So let's that's what you said.
Apart from the internet, if there's an organization that has a brand, yes, so the network here can communicate with via routers.
That's my network student. So let's check the answer. Yeah, that's good. So a server just provides services to multiple users because like a database that shares services and can connect to receive. So it cannot be endpoint. An endpoint is defined at either end of communication, and it cannot be a switch because switches are used to connect segments of networks. So people that choose D remains D2. So the answer is C. So number 2, what is a common network device used to filter traffic? You have 1 minute. Let's wait for people in the cloud. Someone pick D. Okay. We have 1 D. So like everybody agree. Firewall. So everybody pick firewall. Yeah. That's the answer. That's the answer. D. So the third one, endpoints like web server. Which port number is associated with the protocol typically used in this connection? 80. Web server. Which port number is associated with the protocol typically used in this connection? From endpoint to web server. That's what they are saying. You want to connect from your device to the internet, to the web server. So which port number is associated with the protocol typically used in the connection? So the arrow means you are connected from the endpoint to the web server. So what's the answer? You know, people in the cloud are answering already before you. Someone is speaking CC. C. Any other contradict answer? No answer. Your answer. Why did you pick 80? Which one is DNS?
Domain name server. Is it domain name server or domain server? Yes. Domain name server.
So why did you pick C? FTP. 80 is not FTP. It's 80 FTP. 80 is HTTP.
No, sorry, I wanted to say.
So you choose C. You choose C. You choose B. Okay. Since we have more, since we have more C, let's see if that's the answer. Should we continue? All right. So 53 is DNS, right? But that's not the port. So the answer is 8. This is the port for the HTTP protocol, commonly used for web traffic. I even showed you why we are doing the summary. That HTTP is for. So basically, DNS is used to convert your IP address to the domain name. Like we said, you know, the computer don't understand, for example, aptechglobal.com, right? The server will not understand that because it is programmed to understand 1 and 0. So that one will be the one to convert it to 1 and 0 to the IP address of what you are trying to actually communicate with, with the web server. Do you get that? So we change the domain name to the IP address. The domain name like www.shagets. Yeah. So number 4. Let's go. Number 4. An attack against the availability of a network or system that typically uses many attacking machines to direct traffic against a given target is known as what? One minute. Virtual people, we are waiting for you. So what's your answer? So what's the answer, sir? Most of the time, you know, the audience, you don't go with the crowd. Everybody is choosing D. Yeah. That's the answer. That's where we talked about zombies and the botnet. So the group of attack devices that we called botnets, they are the one that they used to actually attack the service. So number 5, let's go. A security solution installed on an endpoint to detect potentially anomalous activity is called what? HPS. B. B. Why not D? Why not D? This will make sense. We have two P's.
Yes, no, why I'm detect D is one different. Incident, that one is allowed to control it.
No, me alone. Anyways. Okay, let's check it out. That's the answer. This is a definition for SIM. They collect a variety of logs, like I said, from different sources, from different devices, to essentially manage and analyze. So it's where you gather everything into one central location, then you can manage it from there. What is a security solution that detects, identifies, and often quarantines potentially hostile software? Anti-malware. What about firewall? I'm not agreeing with your explanation. Let me see virtual people. We have two D, one A. Okay. What is a security solution that detects, identifies, and often quarantines potentially hostile software? A. We have two A's. Okay, people at home. Someone said firewall does not quarantine. Okay. I mean, I think that on-prem people, the cloud people are now getting more outside. So basically, let's go with D first because we have more D's than A. So that's the answer. So basically, a firewall identifies potentially hostile communication traffic. So they filter incoming and outgoing traffic. Yeah, the person explanation, the claimant explanation is actually clear. No, anti-malware does not do that. Number 7. What is the common term used to describe the mechanisms that control the temperature and humidity in the data center? Yeah. Let's wait for people. Maybe they are afraid. B. We have B. We have two B's. So let's go. Let's go with that. Yeah, that's the answer. Number 8.
Sorry, question. I want to see where the one who does questions and moves up. Question. Okay, all right.
Number 8. What is a cloud service arrangement whereby the provider owns and manages the hardware, operating system, and application in the cloud, and the customer owns the data?
Because the only thing is customer owns
So what's the answer? Let me check people at home. Clement, there is nothing like C or D. You've been getting the answer. Why C or D? You can only pick one. It's either you pick C or you pick D. No C or D. So we have how many infrastructure? A, sir. D, A. We have A. Since we have much A, let's go with A and C. What's the answer? D. I told you that. Hold on. Sometimes I told you that you don't go with the crowd. Even some of you know that that's not the answer. But because you have many people saying A, and everybody go with A. And you didn't know it. You don't go with the crowd. You can't be with infrastructure. This is the question. It's straightforward. Okay, let me see. Someone actually got it from here. Clement. I'm not giving you now. You choose A or C or D. He deleted it. No, he didn't get it. So this what is a cloud service arrangement whereby the provider owns and manages the hardware. They are the ones that manage the hardware. The cloud providers like AWS or Microsoft, they are the one managing the hardware, right? So, and the operating system, and the customer owns the data. You take your data to the cloud, right? But the underlay infrastructure is owned by the cloud provider. So that's the answer. It can't be infrastructure as a service.
How does software as a service
include hardware as well? Software as a service is a way of delivering applications over the internet as a service through provider-owned hardware. Like all this, your email is a software as a service. So most of the Microsoft online access, Word, Excel, they are software as a service.
So what is let me see infrastructure.
With infrastructure, the customer typically owns the operating system and the application. So number 9. What is a portion of an organization's network that interfaces directly with the outside world? Yeah, I like that. Part with it. I'll be back. How obvious? How obvious? We have 3 answers for people at home. What's the answer? We have how many D's? We have 2 B's, 1 D. So what's the answer? Don't go with the crowd. Crowd. What's the answer? Okay, let me close this. What is a portion of an organization network that interfaces directly with the outside world? That interfaces directly with the outside world. I even mentioned it today. I didn't mention just ordinary VPN. I've actually discussed about TMC today. I've discussed about VPN today. And I've also discussed about VLAN today. What's your answer, sir? The interface with the outside world. So we have B is more than A. So let's go with the B and let's check the answer. That's the answer now. I even actually discussed it when I came to the class. When I was asking you what was our last listing, I was actually discussing about it like put like a proxy where people coming from outside we interface with. So that's DMC. That's the answer. So number 10, which of the following tools can be used to grant remote users access to the internet IT environment? Yeah, that's the answer. So we missed how many? We missed one. Missed one. Is it one or two? It's just one. It can be harder, or at least it's still like logical ideas. When you get to the exam, these are the things you will still see. Or it can just be more kind of like tricky. Let me put that way. And it will be kind of like scenario based. Maybe not directly like what is a common network device used to connect network, but it will still be something like this. But it will be tricky and kind of like, scenario based, but router will still be the answer. So that's why you have to know the reason why you are picking your answer. So coming up, let's move on. See what do you have here. So these are the terms and definitions that we have. I think we can go through it by ourselves when we share the material to you in the group. So I don't think we need to actually take it all over again. So we can go through this ourselves. These are the key takeaways. These are the types of computer networks. We have LAN, we have VPN, we have PAN, we have CAN, we have POLAN. We even listed some of the things we didn't even actually talk about in the main, material. So you can go through all of this yourself when we share the documents. And we have network devices. We have hubs, we have firewalls, we have printers, we have gateways, we have bridges, we have modems. So, and other network terms. Talk about packet, protocol, Ethernet, Wi-Fi, IP address. The network model. Talk about OSI, stack, and TCP/IP. And we talked about type of IP address. We have IPv4 and IPv6. So IPv4 is how many bits? So IPv4 is how many bits long? Yeah? What did you call it? Why did you call it? Is that called the IPv4 is how many bits? Sorry. IPv4 is how many bits? How many bits? What are IPv6? How did we arrive at the 32 bits? How many optex do we have in IPv4? How many optex do we have? So that's how they arrive at the 32. So we have 4 octets in IPv4, and each octet is separated by dots. That's another difference that we have. So IPv4 is separated by dots. We see 182 dots, 128 dots, 20 dots, 1. So like that's the first octet, the second octet, and the max number of bits you can have in one octet is 255. And that 255 is 8 bits long. Right? 8 bits like 128, 64, 32, 16, 8, 4, 2, 1. If you add everything together, it's going to give you 255. If everything at max, if everything is on, we're going to get 255. Yes. And like we said, one octet is 8 bits. So adding the 4 octets together is going to give you 32. So how many octets do we have in IPv6? It's times 16. Yeah? It's times 16. How many octets do we have in IPv6? People from I beg help me. They want to cheat me here. IPv6 is how many octets? If everything is on in IPv6, how many bits long? How many bits do we have? How many octets do we have in IPv4? 4 octets. And that 4 octets will give us how many bits? How many bits do we have in IPv6? So 128. So that will be how many octets? Oh yeah, if you don't get it, we are not moving forward. People from home, how many? Are you sure? Okay, hold on. Let me show you something. So count it yourself. This is how many octets? This is how many octets? Ah, are you kidding me? Is this going to be an octet? Is this going to be an octet or hexadecimal? So that means you guys don't actually understand. You have to understand, like you have to guess what you are even talking about. So I'm saying it's octet. You are saying yes. I'm saying is this an octet? You said no. So that means you guys are not sure. IPv6 is written in hexadecimal format. Go and look it up yourself. Not wonder. So, and these are the list of protocols, some of the protocols that we have. So port 21 is FTP, which is file transfer protocol. So the secure, part of it is secure FTP. So we have DNS, which is 53. We have Telnet, which is 23, and we have FTP, which is 21. We have ET, which is HTTP. We have IMAP, we have SMB, and LDAP like that. So this is how you can prevent threats in your network. You can use antivirus, you can scan your network, you can use firewall, you can use intrusion prevention system, you can use network intrusion prevention system, and you can use host-based intrusion prevention system. So let's go and do revision on all of these.